Alright, welcome back to the channel, everybody. So it's been a couple days since I've worked on this project. I was kind of stuck at this step, trying to decide what I wanted to do. So before you go on to our next step, you need to decide if you're going to run this at 9 volts or 12 volts. So if you're not familiar with the QMX, it is a 9 volt or 12 volt radio, and that means 9 volts or 12 volts, not 13.8 or anything else. It's very picky. And you will blow it up if you use more voltage than that. So, after much thinking and searching online, I found what seems to be the consensus is that 9 volts is the best voltage to run because the transformer design is more known, it's also more efficient, and gives you more headroom for your finals because they're driving a lower impedance. So, I'm going to do that. I'm going to run it for 12 volts. So what you see here is winding, I believe it's T501 is where we are. Let's see here. We are on step 2.9. Yeah, transformer T501. So there's two ways, well really three ways to wire this, or wind this, excuse me. There's what they call the weird Twisted Sisters transformer for 9 volts, or the really weird Twisted Sister for 12 volts. Or there's the conventional, which my original QMX was wound for the conventional method because the other two methods had not been devised at that point when I built that. So I don't know, at some point I may go back and actually rewind that because it's supposed to really improve the performance of the radio. So, but anyway, so the first thing I need here, we need a ruler, we need our binocular core. There's actually 2 binocular cores in the kit, and we want the larger one. This one's actually part of the SWR bridge, so you want the taller binocular core here. We're going to need our enameled wire. I've got 2 hanks of it. They're both the same size. Used to there were 2 different diameters of wire, but they actually include just 0.3 millimeter, I believe now, instead of 0.3 and 0.6. Got a ruler to measure the lengths. We also are going to need some pliers and a drill. Just any cordless drill should work. You don't necessarily have to use the drill, but you'll get a better twist if you do. So before I forget to do this, the first thing I'm going to do, these ferrite materials can actually be a little sharp and they'll scrape the enamel off of the wire and cause shorts. So what I'm going to do is I've just got, this is just one of those craft knife where you can break the pieces off. So I'm just running this along the inside edge, and notice I'm not pushing. You don't want to cut or gouge into the ferrite, and you don't want to push hard because these are pretty brittle and you can actually break them. So I'm just running this around, making lovely noises. Fingernails on a chalkboard. You could also probably use a file or something else to do this, but I'm just doing it and then feeling with my fingers just to make sure there's no burrs or sharp edges. It's okay for the enameled wire to touch the ferrite, it's not going to conduct, but if the ferrite scrapes the enamel coating off the wire could short to itself and cause you some problems. Man, that is a lovely, lovely noise. You just want that to feel nice and smooth, which it does. Alright, so when you're unwinding these, you want to be really careful because these are very easy to kink and you don't want to put kinks in it. So just take your time and unwind these in a nice orderly fashion here. And I just kind of do like this, kind of straighten it as I go by just putting some pressure on it. Once we chuck this into the drill, it will actually help to straighten out a lot of these kinks and stuff, but we do need to measure this. I'm just gently unwrapping enough. So the first thing we need to do, again, this is for the 9 volts. So if you're building the 12 volt, it's going to be slightly different, and I'm not going to go over that. I do have a 12 volt QMX, like I said, so I might actually, let me think about that. I might actually rewind that guy and put that in this video as well, but so we need one piece of wire that is 24 centimeters, roughly, and one that is 20 centimeters. So This is, put this right on the end. Let's see, so 24. And 20, so we need to unwrap a little bit more of this. Again, you want to kind of see how it's oriented and go with the flow so that you don't kink the wire. Once you get a kink in it, it's very difficult to get it out. All right, and so now I need a 20 centimeter piece. Right there. And I'm sure there's probably a little extra, but you definitely don't want to use all this for this transformer. So what we're going to do now is we're going to take the longer piece, which is this one, and we're going to go halfway in the middle. So I'm going to fold this in half, and we're going to make a 2 centimeter hairpin. So I'm going to come to right here about 19 and just put a twist just like that. Then we're going to straighten him out again. And now we want to lay these on top of each other. Where'd my drill go? If I did this right, they should be roughly the same length. Yeah, pretty close. All right, so I've just got that end chucked into my drill. I'm going to take the other end and just hang on to it with my needle nose pliers. And I don't know if I can get this all in the screen here, but I will try. Watch your little hairpin here. You don't want him to start twisting around. And they say we want about 3 twists per centimeter. So let me undo this guy. I may actually have a little tighter than that. 1, 2, 3, 4, 5. I've got about 5, but that's probably okay. All right, so now we're going to bend 2 legs inward like this and insert it into our core. So on binocular cores like this, that is considered half a turn. So 1 pass through the core is half a turn. So you want this to be very symmetrical. The more symmetrical, the better it's going to work. So there's half a turn. So now we're going to pass each wire, and just take your time, there's no rush here. Pass each wire back through the opposite hole. Again, you don't want to get any kinks or anything, and make sure everything's nice and tight. Okay, so there's 1 turn. Now we're going to pass them back through again to make 1.5 turns. So I'm just going to put some pressure here to keep it from wanting to pull back out. So I'm just putting pressure on the 2 loops we've already got, and then feeding this guy back through. And I'm going to do the same thing here. so this is what we should have at the end. So you have your loop over here, you have your two twisted ends coming out here, and then you've got your, so this makes us 1.5 turns. All right, so now we're going to untwist all the wires that are outside here. I have a feeling this is much easier with the 0.3 wire versus the 0.6. They say that there was no reduction in performance, and actually maybe a slight increase in performance by using the smaller diameter wire. So that's a bonus, that it's really easier to deal with as well. All right, so we've got everything untwisted that's outside. And then we're going to cut our hairpin loop in the middle here. So now we need to scrape the wires. What I'm going to do, actually, rather than scrape, is use a little bit of sandpaper, I believe. For this wire, for this enamel coated wire, you can burn the insulation off. You can scrape it off with a knife or some cutters, or what I like to do, this is probably too high of a grit for this job, but let's see if we can make it work here. We need to be able to measure continuity here. So another piece of equipment I forgot to mention you'll need at the beginning is a multimeter that can measure continuity. Now you can kind of see when you've got this, the color of the wire. I don't know if it comes across on camera, but the color of the copper will change once the coating is gone. All right, so now we're looking for two wires that have continuity between them. So I don't know if you can hear the beep or not, but that's what we're looking for. So we want to find two of these that beep when we touch them. And nothing, so that means it probably don't have enough of the coating scraped off. Oh, there we go. So it's this one and this one, I believe. So those are going to be our secondaries. Let me spread those out and check them again. So this one, yep. Okay, so now this is our center tap, the two in the middle. So we're going to twist these guys back together again. I'm going to try to get these pretty nicely twisted and neatly, because these have to go through the hole in the PCB. And if you get that tighter, it'll be a little easier to poke through the hole there. I forgot to scrape the enamel off of these guys. So our center tap here, get this where you can see a little better. So this guy should have continuity with both of these. Which it does. But there should be no continuity between this guy and any of the secondary wires. If we do have that, then we have a short somewhere. Okay, all of our primaries are together. Secondaries still work. Okay, so that looks good, I think. So now we're done with this guy, and I'm going to switch back to the overhead so that I can install this in the board. Alright, so we've got our PCB, and T501 is right here next to our output transformers, or excuse me, output transistors. So we're just going to bend these wires and stick them through the holes. Easier or younger because I can't see those holes anymore. Okay, so I've got those through the holes, and now I have the binocular core laying flat against the board. So I'm going to just kind of pull on these a little bit to make sure it's tight. Alright, so now we're going to cut. So we just have a couple millimeters. Again, depth perception is hard. We just want a couple millimeters of each of these protruding. I was just near Harbor Freight. Still neglected to get new cutters. Might be able to file these, I don't know. Alright, so I'm going to fold these. They're not very stiff, so they're probably not going to hold very well, but just kind of let that guy stick a little bit. I need to turn mine. The trick to this, we're going to basically melt the enamel coating off of the wire, and so this takes a lot of heat, just like everything else in this process. My solder fume extractor as well. Again, I apologize, I know this is going to be noisy, but we're just going to apply a ton of heat to this pad. Okay, good. And then once we get the solder to flow, we're going to kind of build up a little bit around the wire here and just be patient and heat it up. Same thing over here, just heat up. This one's a trace, it might not take as long. Yeah, that one's already warm. So. Alright, I'm getting my dull clippers here. Alright, now we are going to check for continuity. I'm going to let that cool off a little bit. And we should have continuity between, there's a picture in the book here. So between this lead, or this pin here, the third one, 1, 2, 3. And then this hole. And we don't, so that means we did not get this guy hot enough. Right, so that helps it on. Yep, alright, so now we got continuity there. And we have continuity there. We should have continuity here. Alright, so where would I check? Alright, so let's check between here and here. Yes. Here and here. Here and there. Okay. So now we want to make sure that there's no continuity between ground and any of those points. Nothing there. Nothing there. Nothing there. So now we're going to flip our guy over here and we're going to look for continuity from the end of C510 and ground. So we want to go from, let's see, I don't know that I can read that here. It's the last tiny little component in this stack. And we do have continuity here. I'm just using that there these mounting pins and these rails are ground, so you can just touch kind of any, probably the shield, yeah, the shield of the USB-C. Get this a little better so you can see. So we're just at the very top of this last component, which is C510, and we're trying to measure between ground. We should have continuity in this case. So any of these kind of exposed mounting holes and mounting rails can be used for ground. All right. So that was pretty successful, I think, actually. And the reason we don't actually check the leads, we don't check continuity directly on the transformer, is you might touch the end of the wire and get continuity there, but it's not actually making contact on the board. And so now we know for sure that the transformer has got no shorts, it's got no opens, and it's connected all to the right place on the board. So that's probably the hardest part of this. Now we got a bunch of transformers, excuse me, a bunch of toroids to wind, but the rest of it really shouldn't be too difficult. It's just kind of tedious, and yeah, that's it, just toroids. So I'm going to go get a little tool to help me, and I will return. All right. So now it's toroid time. Okay, so now that we're going to wind L502. So the first thing I've done is I just unwound all of one of the hanks of wire here. I've also got a paintbrush. You can use a paintbrush or a chopstick or something. This really helps. This is a really neat trick. I've seen several YouTube videos of people recommending this to help keep the wires tight on the toroid. You use a paintbrush handle or a chopstick or anything that's kind of tapered, and the toroid will, you know, slide up and down. So basically it allows you to pull it down to hold the previous turns tight while you wrap, and you can slide it up just enough to stick the end of the wire back down. So we're going to take the first our T30 or yeah T37-43. We want to put 10 turns on this. So Hans recommends there's a way to wind these such that you will always end up on the right holes basically on the board, and that way is start with your first turn coming over the top and then wrap in a counterclockwise direction. So that's what I've got right here. So I've got our first little turn. So we're doing 10 turns here. So what that means is we're going through the center of this toroid 10 times. So every time you go in the middle, that's a turn. So there's one turn. Pull this guy down. Now when you're pulling this wire through here, one thing to keep in mind, again, like we mentioned earlier, this stuff wants to get twisted and kink up, so make sure as you're pulling it that you don't introduce any kinks into the wire. Okay. There's two. See, that was getting ready to kink up on me, so you have to kind of watch it as you're wrapping. There's three. Oh, another kink getting ready to form there. I don't want to let that happen. All right, I think that is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So there's what it looks like right now. I'm going to spread all of these turns out evenly across the core. And just slide them around until they're all pretty evenly spaced. So we've got that, and he's going to go right here. So we have, let's see, one that comes out of the middle. That's going to go there, and that guy's going to go there. And then he's going to lay flat. So again, you can scrape the enamel off. That actually makes this part much easier. And I'm just going to get these filled up with solder first. actually laying pretty good. I think I do want to try to put a little bit of pressure on him though. Just to get the lay a little flatter. Alright, so I've got my hole filled with solder. Clip off our little leads here. And we're just going to apply lots of heat. Alright. He's laying good. Try to squeeze these, spread these out just a little bit better. Alright, so now, even though this is an inductor, a DC of course, it's just a resistor, and in this case it's basically a 0 ohm resistor. So I'm going to check for continuity, but I'm going to try to make sure and just touch the pads and not any of the wire, or not any of the wire that is on the toroid. Alright, well, I'm happy with that. And I think what I'm going to do, once you've wound one toroid, once you've seen one toroid wound, you've seen them all. So I think what I'm going to do is just continue on, because there's a bunch, and there's no reason to bore you with all of that. So I'm going to go ahead and wind all the, well, maybe not all the rest of these, but if there's anything interesting, I will stop and let you know. But for now, I'm just going to continue through the instructions, winding these toroids and installing them where they go, and I will be back with you once we get to the next step. So, see you then.